Can everyone see us? Awesome. Okay, well, thank you all for joining this webinar. This is just to go over our new monochloramine and ammonia sensors. My name is Jesse Carr. I am a product manager here at Palintest. And this is Sharia. He's the head of sales for our EMEA region. And so today we're just going to take you through our new sensors, some of the applications, some of the specifications, and then we're going to do a live demo for you of our monochloramine test. But before we do any of that, we're going to jump into a little bit about Palintest and some of our history and what we do. So Palintest manufactures water testing equipment, and we operate within these four segments. So drinking and wastewater, rec water, industrial water, and humanitarian water. And Palintest's mission is to safeguard water for everyone every day. And we do that by providing testing solutions within these four segments. So today, we're going to be focusing on the drinking and wastewater segment with our new sensors. And a little bit more about Palintest. We are based out of the northeast of England, up in the Newcastle area. And we have a diverse sales and R&D and operations team to support you throughout your customer experience. Here's just a little bit about our team. Yeah. So a little bit more about our product. We offer a wide range of devices from photometry to electrochemistry to microbiological kits. We offer dozens of parameters to be tested with these devices. But yes, like I said, we're going to be focusing on the electrochemical side of things today. So this is going to be focusing on our Chemio instrument. With that, we also just launched our digital data platform known as Palintest Connect. So this will allow users to have a digital test log that is accessible via the cloud database to look at all your results, including geography, test results, like who did the test. It just allows broad tracking across your testing regime. So now we're going to explore why you actually want to test for monochloramine and ammonia. And to start with that, we're going to dive into what is monochloramine. So monochloramine is a disinfectant that's used in large building applications and in areas where housing and businesses are sparsely populated. So anywhere where you have just really long pipe networks, basically. And monochloramine is formed by combining ammonia and chlorine. And to do this right, you have to strike a very specific ratio between those two compounds. So if you have too much chlorine in the sample, that can lead to the development of harmful di and trichloramines, which can affect the taste and smell of the water. And if you have too much ammonia in your mixture, that can lead to nitrification in the pipes and a buildup of biofilm within the pipes, which can also affect taste and odor and cause safety issues. So yeah, main takeaway is monochloramine is a stable disinfectant, so it's used in long pipe networks, and yeah, it's better for preserving the taste and smell. So monochloramine is used mostly in secondary disinfection. So that's different from primary disinfection, in so much as primary disinfection kills all the pathogens initially, whereas secondary disinfection is more of that booster shot to keep those harmful compounds and pathogens away. So typically, secondary disinfection happens after primary disinfection, and then the water is sent off to homes. And at some of these businesses, like campuses or hospitals, they will have disinfection units within those systems just to kind of re-up on those disinfection residuals and keep their water clean. So yeah, monochloramine is more for that long-term protection. Now getting to the ammonia side of things, ammonia is a harmful pollutant in water. Releasing this into the environment can suffocate fish and lead to eutrophication, which causes marine dead zones within the ecosystem, which is not good. And it is a tightly regulated compound. Think of Section 82 in the UK, where wastewater utilities are having to monitor the ammonia levels with up and downstream from their effluent sites. So it's a tightly monitored compound, and it's really good to get a handle on how much you are releasing into the environment, so that whether your process for removing ammonia is really working. So a little bit about how ammonia is removed in the wastewater process. So crude effluent will come into a wastewater treatment plant, typically at around 15, anywhere from 15 to 100 milligrams per liter of ammonia. And then through the whole wastewater treatment process, including screening, clarification, filtration, the whole gamut, um, the ammonia is removed, particularly at that bioreaction step. So that's where you see those big aeration tanks at wastewater treatment facilities, where bacteria will basically eat the ammonia and break it down from ammonia to nitrate to nitrate to nitrogen gas, which is then just released. And the goal is that by the end of that whole process, the wastewater treatment is releasing water back into the environment at about 0.5 to 3 milligrams per liter of ammonia, which has been deemed a safe level to release back into the environment. And yeah, this just helps protect our oceans and streams and natural resources. So introducing our new sensors. There are 3 new sensors and 3 new tests. The first one is a standalone monochloramine test that just uses one sensor. The second one is a combination test between monochloramine and ammonia, the lower range of ammonia. And then the third test uses a separate ammonia high range sensor, and that's just focused on that wastewater side of things. You can see the test times and temperature ranges here, so take a screenshot if you want. If not, yeah, this will be posted on our YouTube, so you can go back and reference it. And I'll hand off to Sharia to talk a little bit more about how these tests actually work and some of the science behind them.
Thank you, Jesse. That was very insightful as you shared why these tests are being developed. Now we're going to go a level deeper into the technicality, the chemistry that's happening behind the scenes. So here's a short video which explains the related chemistry of these two parameters. So the nitrogen is in different forms. There's monochloramine, which is combined with chlorine, and then there's ammonia, which is not in monochloramine. So the sensor firstly is measuring the element that is combined with chlorine, that is the monochloramine. And this is using our monochloramine sensor, the disinfectant that you want in water. And the nitrogen which is not combined with chlorine is called the free ammonia. Now the free ammonia can exist in 2 different forms, either the ammonium ion or NH3, and it depends on the pH. They exist in equilibrium, their ratios, but in very, very high pH, it's mostly present in the form of ammonia. So what our sensor does is it will first react with chlorine, the nitrogen reacts with chlorine, and then it would convert everything into monochloramine. And that's how we are able to measure both. We are able to measure the nitrogen that is already combined with chlorine and the nitrogen that is free. And together it's consisting of total ammonia. So here's the relationship between the 3 different species and how they operate. Our Cameo, when you do the follow step, you will see all the 3 results, all the 3 measurements. So I talked a bit about the chemistry of it. Now we're going to focus more on the user benefits. So as a user, you don't get to see all the chemistry. That's all happening behind the scenes. That's all built in the Cameo system. As a user, you will really see a simple, easy to follow step procedure. And Jesse's going to do demo in a minute, and he'll show us, like, you just add 6 drops of liquid and you put a sensor, and 2 minutes you get the result. So that's how simple Cameo is. And this is because we understand that the field operators, they are doing so many jobs in a day. For them, it's about getting to the water test, making a quick decision, moving on to the next task. And insight we have while developing this sensor was that the current methods to measure monochloramine, they are complicated and they are temperature dependent. So the common photometric method, it does depend, the test time depends on the temperature. So if it's really cold weather, you might have to wait 20 minutes, whereas if it's hot water, you have to wait 2 minutes. And that does introduce error into the system because you have to make sure you're using the right test time at the right temperature all the time. Whereas with Cameo, you remove that temperature independence because the sensors are already calibrated for that, which means you just spend 2 minutes and you are able to get that test result. So the procedure is very repeatable every time. Another insight we have from our customers is that the Nestler method is hazardous and they spend a lot of effort, logistics, and cost to dispose of the waste material, the tube test of Nestler, which is why the idea was to come up with a safer method for measuring ammonia. And as the regulations are getting stricter, we see the companies moving over to much safer methods. So now I will talk about the customer feedback on these. So these are products, they were not designed in-house in lab. Uh, they were also developed along with our customers. We went out in the field, we asked for their feedback, we saw how they use the current test, what challenges they face, and based on that, we came up with the new solution. And that is really valuable part of our new product development process. So I'll share you two of the case stories we have here. On the left, we have Sanepure, which is an Italian manufacturer of monochloramine generators. So they have various installations in different parts of the world, and they ensure that the monochloramine is generated on site very reliably. So we went and we worked with their research team to actually understand how they're testing it currently and how we can develop the Chemio system to make it easier, faster, and simpler. And the insights we had was around the hot water temperature. The test was not reliable on the photometric methods. The testing time was also a challenge. So we simplified a lot of things around there. We made it temperature independent. We made it pH independent, which means all of that is calibrated in your system. You do, as a user, you don't have to use compensation to get the right result. When you're out in the field, you want to do quick tests, so the wider range as well means that you don't have to let the hot water sample cool down because the range of the temperature range on the sensor allows you to test for both hot and cold water effectively. So we are really proud of that, and we thank to the Sanipur team as well for all the feedback they have provided us in the ongoing development process. And the next one we have is Severn Trent Water for the people joining from outside UK. It's like one of the biggest water company we have in UK, supplying to millions of people around the Midlands, and they have to comply to the legislation, which is why they are also testing ammonia to ensure the safety of the rivers. Currently, many of the field operators they use the traditional methods, and we wanted to try the safer method. So we have been working closely with the team to understand how that works out and how the sensor can improve the safety side of the Nestler testing method. So now we are here where we're gonna be showcasing the live demo of these sensors. And Jesse here, he has got the camera set up. He has got all the equipment accessories he needs to showcase the new monochloramine test. So without further ado, I'll pass over to Jesse to start presenting, and I'll switch over. So Jesse, all over to you now.
Awesome. Thank you so much, Sharia. So yeah, here we have our Chemio system and our monochloramine sensors and our monochloramine agent. So to do this test, it's a pretty simple procedure. You just have to perform tests and it's going to prompt you to scan one of our sensors. So you're just going to scan this barcode right here. That'll load in the batch information. So all of the calibration information is stored within this. So we're good to run the test now. Just going to open up the device, load in your sensor. So you're going to tear the foil off. Make sure not to touch the surface of the sensor. Make sure to insert it with this red side facing down to the slot in the machine. Make sure it's fully seated. And then you're going to add your monochloramine reagent. So this is just a compound to help with the conductivity and some of the pH buffering. Add 6 drops. And then we're going to add our sample that we want to test. See if I can't spill this. There we go. Just going to fill it up to the top of that vessel. And in terms of test prep, that's all there is to it. At this point, we can just close the arm and let the Chemio do its thing. Since we have an extra minute and a half together, I figured it'd be good to go over, some of the science behind our sensors for those of you who are not familiar. So this is one of our Chemio sensors. It is a printed circuit board on a plastic substrate. So we have 4 different electrodes here. The 2 outermost electrodes are working electrodes. So that's where the chemical is actually dosed and where the chemical reaction actually happens. So the chemical reaction will happen with whatever analyte, and then the Chemio will read the electric signal produced by that reaction and turn it into a concentration. These other 2 electrodes are the working and counter electrodes. So they basically just give the machine a baseline to measure off of. Yeah, as you can see, it's relatively small. And one of the perks of using electrochemistry is that it allows you to test turbid samples because we're not looking at the color change of the water. We're just measuring the chemical reaction happening on these working electrodes. So yeah, hopefully you learned something new there. And as we wait for this test to finish up, I guess I'll just clean up my space a bit.
Also, I would like to mention, as you can see here, the instrument that's field usable. So you can keep it on a table, but you can also carry it in a van. So it's IP67 waterproof. It is IK08 impact proof, which means it's designed for both like harsh field environments, but also the lab settings.
Yes. And okay, our test is done. As you can see, we got our monochloramine reading. And if you want to look and get some of the details of that reading, just click on details and you can see the temperature of the water sample, the time the test was performed, the date, and the batch ID for that sensor information. And if you wanted to do another test, let's say you're, running, multiple tests back to back, you just hit repeat test and it guides you through the setup for the repeat test. So remove our sensor, discard our sample, and then if we want to do best practice, we can open up the device and just wipe down these electrodes to make sure they stay nice and dry and they don't corrode or anything. And you can close the device and that's it. If you wanted to look back at your test history, we have a nice handy dandy history tab right here. And you can go back in and look at all your past information, all your past tests, or even add notes within each test. So yeah, it's a really helpful test log and a very simple and straightforward procedure.
Thank you, Jesse. That was really insightful demonstration of the sensor, how the test method works. We are nearing towards the end of the presentation, so if you have any questions, please feel free to use the chat function, drop in your questions, and we'll pick up towards the end. We have just some final information around the ordering because these sensors are now available to order. So Jesse is gonna touch upon some of the information here before we close off.
Yes. So In terms of ordering kits, you can see our sensors come in 100 packs, and you can see the product codes there. And these sensors are able to be used on both our chemio disinfection unit and our chemio multi unit. So, please reach out to your sales rep to get further ordering information. And yeah, so here's the ordering info for our chemio multi. And yeah, if there are any questions, feel free to pop them in the chat, and we'd be happy to answer.
Sharing my screen. So we're gonna read some of the questions that have come up in the chat. So firstly, the question is, can Connect by Appellant test be accessed remotely? So the answer is yes. There are a couple of ways you can transfer the data. As Jesse showed, there's a test history on your instrument. And once the test history is there, it can be sent to the cloud platform. Now you can send it right there and then, which means you can also record the GPS coordinate of the test, which is especially valuable when you are out in the field and you're testing remote locations. You can trace back where the test was done. But also you can do like a full bulk upload. Let's say you did a couple of tests in a day, you come back in after the end of the day and you can do a batch upload of all the test results. You can do it via the QR code. And you also have the results available when you connect your instrument to a computer. So various couple of ways, but this ensures that the user, they are able to trace the testing history and have a traceability.
I can take the next one. So Lawrence asked, what is the disposal protocol for this sensors? And all of our sensors are categorized as general waste. So it's as easy as just tossing them in the bin. Whereas with alternative methods like the Nestler method, that includes a lot of it's a process. You need a special bin that needs special pickup, and it increases a little bit of the friction for disposal, and as well as the cost. So yeah, our sensors can just be tossed out. Simple as that.
Yeah, the sensors don't have any hazardous material on them. I would add to that we have an online STS portal which shares all the changing the chemistry components. So wherever you are in the which part of the world, there are different regulations, and you can always refer to the local regulations as well when considering what is composed of these sensors.
Yeah.
Do you want to take the next one?
Yeah. So in terms of placing an order, you can just reach out to our sales team. I believe it's sales@palintest.com to place an inquiry. And our talented sales team will take good care of you. Yeah.
Next.
The last one is, how many sensors are in a pack, and do they have any storage conditions? So, like the last slide showed, 100 sensors come in a single pack, and they're stored just at room temperature. And in basically any humidity and environment. I will note that these sensors have a 6-month shelf life. So yeah, I'm not sure if that was included in our spec slide, but yes, no special storage conditions, and 100 sensors come in a pack.
Yeah, we'll give it 30 seconds more in case there are any questions coming up. I can see another question has popped up from Steven. With it being a new test, does the age of the instrument have an effect on the test being performed? No. So if your instrument is within calibration, it's passing the check standard. Your instrument is capable to do all the testing that it needs to do. All you need to do is do a firmware update. So you have the new testing parameters with you. And when you order the sensors, you will be able to continue your testing as usual. So there's no special requirement of your instrument having to be upgraded. Your existing instrument is good to go.
Mm-hmm.
Thank you, Stephen. Yeah, I just wanted to also add to that while we finish off that this session is recorded. We'll share you the recording after the presentation. And we have a series of webinar coming up, so stay tuned. We'll keep you posted with different topics. If you have any special requests around which topics we should cover, please reach out to us and let us know. We have another question from Andrew. Do you want to pick this up?
That's all you.
Okay. So Andrew has asked how often should I get my instrument serviced by an authorized service center? That's a good question, and Andrew. So these instruments, they are performing a really crucial job. They are used in regulated environments, and it's really important to make sure they are calibrated, because they're testing sometimes very sensitive levels of chemicals in water. Hence, we recommend annual calibration. That is the best practice to make sure you are getting the most accurate results. And we have our parent test headquarter in UK, but also we want to expand to a global service network. We have some authorized service partners across many countries operating now, and we plan to continue to expand our footprint to make sure our customers receive the best service. Okay. I thank you all for being here today. It was really insightful. Oh, one last question that popped up. How often should I run the check standards? So that's a really good question. I get that question every time I do a customer visit. And the answer is it totally depends on your requirement. The time to run a check standard is less than 60 seconds. But all it allows you to do is make sure that instrument is within calibration. So the more the better. But of course, some customers prefer to do it on a weekly basis. Some do it morning, some do it evening, some do it 2 times in a day. So totally, you want to make sure that all the testing you're doing is compliant and you're making sure your instrument is within calibration. So we offer the capability, but as per your processes, you can set up a testing frequency for check standards. Thank you, Andrew. Great. Thank you for all the questions, and thank you for the engagement here on the webinar. Stay tuned and have a nice day.
Yeah. Thank you all.
Bye.
Take care.